Welcome everyone. In this video lecture, we will see the definition of convergence in probability, and we also see one of the law where this type of convergence is used, and that law is called Bernoulli's law of large numbers. And at last we see one example based on that. So let's start the definition of convergence in probability. What we mean by convergence in probability? आपने convergence of a sequence पढ़ा होगा. ये convergence in probability है. A sequence of random variables x1, x2, xn and so on is said to converge in probability to a constant a if for any epsilon greater than 0 we have the probability mod xn minus a less than epsilon. As n approaches to infinity, the probability of this approaches to 1, or the probability that difference between xn and a is greater than epsilon. This probability approaches to 0 as n approaches to infinity. Then we say that xn converge in probability to a as n approaches to infinity. Means if we have a sequence of some random variables and suppose this is point A, so if the difference between xn and a is, अगर ये सीक्वेंस a की तरफ कन्वर्ज कर रहा है तो ग्रेजुअली क्या होगा, as you increase the value of n, this difference between xn's and a will keep on reducing, right? And the probability of this, that this difference is less than any positive number, its probability approaches to 1 as n approaches to infinity. इस चीज की probability कि xn का और a का difference epsilon से कम होता जाएगा as n approaches to infinity, इसकी probability 1 की तरफ अगर approach करती है, then we say that the sequence converge in probability to a constant a. In other words, we can also say that if the difference between xn and a will be greater than any positive real number, its probability approaches to 0. Means you are getting the difference less than epsilon, so obviously the probability of getting the difference greater than epsilon will approaches to 0 as n approaches to infinity. So this is called a convergence in probability. जैसे आप जब कॉइन टॉस करते हो तो आप मान लीजिए आपने 10 बार वन बार कॉइन टॉस किया, तो उस समय हेड आपको मिला, तो ये हेड मिल गया, तो आपने हेड की फ्रीक्वेंसी नोट कर ली, तो प्रोबेबिलिटी 1 हो गई. फिर आपने कॉइन को 2 बार टॉस किया, तो आपको हेड एक बार मिला, तो अब हेड की प्रोबेबिलिटी 1/2 हो गई. फिर आपने कॉइन को 3 बार टॉस किया, तो हेड की प्रोबेबिलिटी मान लीजिए आपको हेड एक बार मिला 3 टॉसेस में, 1/3 हो गई. So this, when you increase the value of n or increase the number of tosses, the probability ultimately approaches to half. So here we are noticing here x is a random variable, where this random variable can be anything. You can take this as random variable as denoting the number of successes, and a is any constant number, and the difference between x and a as n approaches to infinity will be less than epsilon if actually the sequence is converging to this number. So based on this convergence and probability, we have a law which is called Bernoulli's law of large numbers. What is this law? There are some conditions before stating the law, that if we have n number of trials of an event may be like tossing of a coin or throwing of a die, like that. Each trial resulting in success or failure means in each trial either you are having success or you are having failure. Like you can call getting head is success and getting tail is failure. So when you toss a coin, either you will get success or you will get failure. Similarly, in throwing of a die, you may get you may call getting 5 as success and any other number as failure. So either you have success or you have failure. Okay. If x denotes number of success in n trials, x क्या है? जितनी आपको सक्सेस मिली है इन ट्रायल्स में वो नंबर है with constant probability p of success for each trial. हर ट्रायल में सक्सेस की प्रोबेबिलिटी कांस्टेंट है और वो p के बराबर है. Then expected value of x is equal to np because this is a Bernoulli binomial distribution satisfying the conditions of binomial distribution. So x follows binomial distribution here. So expected value of x, that is mean of x, will be equal to n into p, where n is number of trials and p is the probability of success. Variance of x will be npq, where q is 1 minus p. The variable x upon n, this variable denotes the proportion of success or relative frequency of success. Means n trial में जितनी बार आपको success मिली, ये proportion है success का, और percentage you can call, or you can say the probability, जिसे हम probability कहते हैं, ये proportion है. Where if you find the expected value of this variable, then it would be 1 upon n into expected value of x by the property of expectation. It is equal to np upon n because expected value of x is np. So it is equal to p. And variance of x upon n is equal to 1 upon n square into variance of x, that is equal to 1 upon n square into npq. So this is pq by n. So we are dealing here with x upon n, not with x. We are dealing here with x upon n, that is proportion of success. Then probability that the difference between x upon n and p is the probability of success, and this is just the proportion which is varying as n is changing. As n की value अगर 1 है तो it may be 1, means अगर x आपका हेड एक बार आया एक ट्रायल में तो इसकी वैल्यू 1 हो जाती है. फिर आप n की वैल्यू जब 2 लेते हो, 2 बार जब आप कॉइन को टॉस करते हो तो आपको हेड 2 बार भी मिल सकता है, एक बार भी मिल सकता है. तो ये प्रोबेबिलिटी 1/2 हो सकती है मान लीजिए. तो ये प्रोपोर्शन है. तो जैसे जैसे n की वैल्यू इंक्रीज होगी, इन दोनों का जो डिफरेंस है p इज हाफ. तो ये वैल्यू और ये वैल्यू, इन दोनों का डिफरेंस एक टाइम ऐसा आएगा, n की वैल्यू आपको ऐसी मिलेगी कि इन दोनों का डिफरेंस एनी पॉजिटिव नंबर से छोटा हो जाएगा, मीन्स ऑलमोस्ट जीरो के बराबर हो जाएगा, ये दोनों इक्वलेंट हो जाएंगे, एंड दिस प्रोबेबिलिटी अप्रोचेस टू 1, or in other words, the difference between x upon n and p will be greater than epsilon. Its probability approaches to 0 for any epsilon greater than 0. So we can say that x upon n converges in probability to p as n approaches to infinity. Means हम इस रेशो की probability कह सकते हैं p के बराबर हो जाएगी as n approaches to infinity. So this is called Bernoulli law of large numbers. तो हमें ये प्रूफ करना है, इसमें ये probability हमें प्रूफ करनी है, इसकी probability will approaches to 1 as approaches to infinity, or we have to prove this. तो क्योंकि हम अब वेरिएबल x के साथ ना डील करके x अपॉन n के साथ डील कर रहे हैं, लाइक, और जो मैंने आपको इससे पहले वाले लेक्चर में शेबिशेव इनइक्वालिटी के बारे में बताया था, that is this, which is for the variable x. ये इसके दो फॉर्म्स हैं, एक फॉर्म है k फॉर्म में है, k is any constant positive integer, and this is in terms of variance when we replaced this k sigma by any by the product of these two by any constant c. So what we will do is we use this inequality, but we replace x by x upon n. And this mu is the expected value of x, so we replace mu by expected value of x upon n. And this is the variance of x, so we replace this by variance of x upon n. So what we will get, replace this x by x upon n minus mu is expected value of x upon n जो हमने अभी find की हुई है, p. So here is p less than, c की जगह एप्सिलॉन ले लिया है बिकॉज हमें ये प्रूफ इन टर्म्स ऑफ एप्सिलॉन करना है, इसलिए इस c को हम without any loss of generality we can replace this by epsilon. Greater than 1 minus variance of x is variance of x upon n, which is pq by n, pq by n into epsilon square. Mark this as 1. p और q क्या है? Probability of success. ये किसके बराबर हो सकती है in terms of tossing of a coin? मैक्सिमम वैल्यू कितनी हो सकती है? p और q का सम 1 होता है, आप कॉइन को छोड़िए, आप ये बताइए कि p और q की मैक्सिमम वैल्यू कितनी हो सकती है? हाफ हाफ हो सकती है। इसका मतलब इन दोनों का जो प्रोडक्ट है दैट विल बी लेस देन और इक्वल टू 1/4. सो दिस expression pq by n epsilon square will be less than or equal to 1/4 n epsilon square. इसको हम 1/4 epsilon 4n epsilon square से लेस स्मॉलर लिख सकते हैं इस एक्सप्रेशन को। तो यहाँ पर 1 माइनस पी क्यू बाय एन एप्सिलॉन स्क्वायर है, तो क्योंकि आप माइनस से मल्टीप्लाई करेंगे तो लेस देन वाला साइन ग्रेटर में कन्वर्ट हो जाएगा एंड देन ऐड 1 टू बोथ साइड। सो वी हैव, इस एक्सप्रेशन की जगह हमें क्या मिला कि ये किससे बड़ा हो गया? इससे। अब हम शेबिशेव इनइक्वालिटी का सेकेंड फॉर्म यूज करेंगे जहां पर वी हैव लेस देन इनइक्वालिटी हियर। तो वहां इस इनइक्वालिटी में भी हम x को x अपॉन n से जब रिप्लेस करेंगे तो हमें ये एक्सप्रेशन मिलेगा, and this is equal to pq by n epsilon square which is less than 1/4 epsilon square. We have obtained the same thing जो हमने इससे पहले वाले एक्सप्रेशन के लिए फाइंड आउट की है। अब एप्सिलॉन इज आर्बिट्ररी, एप्सिलॉन तो आर्बिट्ररी है, एन और एप्सिलॉन फिक्स भी है, एन वेरी कर रहा है, तो जैसे जैसे एन बढ़ेगा दिस होल term will approaches to zero as n approaches to infinity, and this probability is less than this term because this is approaching to zero and probability can't be less than zero, so this approaches to zero as n approaches to infinity. And ये वाला जो स्टार वाला एक्सप्रेशन है, ये ये टर्म किससे बड़ा है, इससे, और ये टर्म इस एक्सप्रेशन से बड़ा है, तो अल्टीमेटली हमारा ये वाला प्रोबेबिलिटी वाला एक्सप्रेशन किससे बड़ा हो गया, इस एक्सप्रेशन से, एंड दिस एक्सप्रेशन इज ग्रेटर देन वन माइनस वन अपॉन वही, ये चीज यहाँ लिखी हुई है। अगेन बाय द सेम लॉजिक, एप्सिलॉन इज फिक्स्ड as n approaches to infinity, this term approaches to zero and this whole term approaches to 1, but this probability can't be greater than 1, so this probability approaches to 1 as n approaches to infinity. So from both forms of Chebyshev inequality, by just replacing x by x upon n, we can obtain the desired result. आपको कुछ नहीं करना है, केवल x को x upon n से रिप्लेस करना है। जो म्यू है that is the expected value of x, तो आपको यहाँ expected value of x upon n लिखना है, and this sigma is the variance of x, so we have to use here variance of x upon n and nothing, and you have to just simplify, you will get the desired expression. Just go through the proof once again if you have not understood it. I am sure that you will get it easily understood if you have studied the Chebyshev inequality. Let's see one problem based on this. Use Chebyshev inequality to determine how many times a coin must be tossed in order that the probability will be at least 0.9 that the ratio of observed number of heads to the number of tosses will be between 0.4 and 0.6. एक कॉइन को हम कितनी बार टॉस करें कि जो रेशियो है ऑब्जर्व नंबर ऑफ हेड्स का टू द टोटल नंबर ऑफ टॉसेस, वो रेशियो 0.4 और 0.6 के बीच में लाई करेगा, इसकी प्रोबेबिलिटी कम से कम 0.9 हमें मिल जाए। मतलब हमें ये प्रूफ करना है। ये अगर हमें ये गिवन है तो n क्या होगा, तो शेबीशेव इनइक्वालिटी हम ग्रेटर वाली यूज करेंगे क्योंकि हमें यहाँ ग्रेटर वाला पार्ट चाहिए, तो ये ग्रेटर वाला एक्सप्रेशन वाला इनइक्वालिटी है। यहाँ पर हम फिर से x को x अपॉन n से रिप्लेस करेंगे and mu is replaced by expected value of x upon n and variance is replaced by variance of x upon n. Just find the bounds on x upon n by simplifying this, and this is nothing but pq by n epsilon square. We have done it a few moments ago. So we have this bounds on x upon n where p is the probability of success. Here success is the number of heads. Getting head is the success. So probability of head is 0.5 minus epsilon less than x upon n less than 0.5 plus epsilon greater than 1 minus 1 upon 4 n epsilon square, because this is less than or equal to greater than or equal to 1 minus 1 upon 4 n epsilon square. We have obtained this inequality. अभी ये मिली है आपको, ये किससे बड़ा है, ये इससे बड़ा है, तो इस वजह से ये वाला एक्सप्रेशन इससे बड़ा हो गया. Now to get 0.4 and 0.6, what we do is we take epsilon as 0.1. So we have this expression. Ultimately, we are given this equation. So to get to find the value of n, this must be equal to 0.9 because we want this to be greater than or equal to 0.9. So this must be equal to 0.9. So I'm putting this expression equal to 0.9. By solving it, we'll get n is equal to 250. Okay. So don't forget to subscribe my channel for more new videos on this subject. Thank you very much.